I am Romain Gvozeki. I'm working in CEA in Grenoble. CEA, is a big research center, RTO, and we are working in many fields dedicated to development, especially for industry, and we are closing the gap between academics and industry. This project, I would like to present the activities we are doing in the frame of Fastlane, and typically it concerns the power module that is under development, especially with Valeo, in which our contribution is on the modeling of the behavior of this power module. Typically, we start from the 3D model of this power module that include a lot of elements, mechanical parts, connectors, devices, base plate, AMB, and so on. And to have a good modeling, electrothermal modeling of this power module, we need first to simplify this mechanical design to extract only the electrical parts. From this, we are setting the extraction methodology, that is to say the expressions of the parasitics between the different input and output of the full circuit. So after simplifications of the geometry, we define this port corresponding to the device, to the DC minus, DC plus, out, and so on. And after that, we have to run extensive simulations that will extract all these parasitic, these inductance, capacitance, and resistance that are frequency dependent from many physical phenomena, such as skin effect and or behavior of the materials with frequency. This frequency dependent parasitic matrix is then used to estimate these full parasitics that will have a strong impact on the behavior of the power module, that will induce overcurrent, overvoltage, and ultimately will impact the losses or also the reliability of this module. It is some basic example. But then you can see that we have to run a full simulations framework in which we have the different model of the device, electrical model. We need to model also the capacitance bus bar because these capacitor banks may have a strong impact on the behavior. We have this the frequency dependent S matrix that is very dependent on the power module architecture. And from this, we are able to run simulations from many conditions, typically at different level of voltage, current, and with that we are able to estimate the losses, the conversion efficiency, the different stressor of the device, and that will help us to estimate what could be the impact in terms of temperature. For us, simulations is like virtual prototyping. In fact, instead of spending time, money, and materials to run many prototypes, you can analyze the impact of different design options, device performances, or also with a full simulations framework. You can estimate all the different command control. For example, you want to change the current because you are accelerating with your car, or the voltage is changing due to the battery level of charge. We can estimate it will impact the device internal behavior in terms of current and temperature. And then from that, using aging model that are found in literature or delivered by a device manufacturer, you can estimate what could be the impact on the lifetime of your system. So for me, it is a way to be more sustainable because you can improve the full lifetime of your system. And also it is a matter of efficiency. With simulations, it is much more effective to have a full working prototype at the first trial not only based on trials and error approach. Okay, in the future, perhaps right now there is already some impact because there is many innovations running in parallel in Fastlane at material level, device level, and all the activities we have to perform for improving these different aspects from material, device, module or system, in fact, is also a progress in knowledge. So for me, the first benefit or impact of Fastlane is a global increase of the knowledge for silicon carbide device and their applications. Also in terms of methodology. For longer term, this new device will benefit to the main use case of Fastlane, okay, automotive applications, but also industrial applications such as electrolyzer or short circuit breaker. But in fact, they will benefit for all domains where you need power electronics for energy conversions in the day-to-day life or solar plant, wind farm, and whatever you want. I'm quite enthusiastic.